Hey everyone, welcome to Homeschool and welcome back to Class 11 Physics series, and we are with the chapter Motion in a Straight Line, where I have completed all the concepts except one topic, that is all about graphs. Okay, say graphs actually makes life quite easier because most of the difficult problems that you feel difficult to calculate using formulas can be calculated easily using graphs. Okay, so to some extent graphs are used to describe about a motion. Looking at a graph, we can come to know many things about a motion, right? So today we are going to discuss everything about graphs. How can we plot a graph when a information is given, and from a graph what all the informations that we can take and use it to calculate a problem, all that we will discuss. Definitely video is going to be a very helpful video, and you get a kind of confidence after watching this video, so don't miss it out. Watch till the end. Fine. See, coming to a graph, say everybody must have had a basic idea how to plot a graph, right? So graph in the sense you will have two axes, one is x-axis, y-axis with a particular scale. You know what, with the given information we know how to mark the points and then join the points. We may get a straight line or we may get a curved line. That line, whatever the line that you plot, that is called as graph, and that line or a curve will tell you lots of information. Okay, so here our motion is also very well described by graphs. Okay, so we mainly study about three types of graphs. So the first one is position time graph. So this is a very simple graph, but it's a very powerful tool that can tell about many important things. Okay, so we learn a lot of things from this position time graph. Okay, so in short we can also call it as xt graph, right? Fine. And the second important thing is velocity time graph. Even this can make our things quite easy about solving numericals of acceleration. Okay, so velocity time graph, in short we can call it as vt graph, right? So two graphs are very important, and they can act as a very powerful tools to solve all your problems. Fine. And coming to the third type of graph, but we don't concentrate this graph too much for your level, that is acceleration time graph. Acceleration time graph. Okay, so in short we can call it as AT graph. Okay, so we don't have much to study about this graph, but definitely you need to focus these two graphs, right? So first and foremost, let me quickly go for position time graph. So I am talking about xt graph, right? Okay, we all very well know that graph will always have two axes. One is a vertical axis and the other one is horizontal axis, right? See, always time is taken as horizontal axis. See, we plot time in horizontal axis. Why only time is taken in horizontal axis? Why not x? It's because time is independent. Okay, so it doesn't depend on anything. So the independent variable is always taken in, the horizontal axis, right? So in a vertical axis, position is taken. So x in the sense position here. So position is taken in vertical axis and time is taken in horizontal axis, right? So, and for example, imagine you have this information. See, this is x and this is t. Say at time t is equal to 0 seconds. Let me take time in seconds, position in meters. Okay, so when t is equal to 0, your x is also equal to 0. Okay, but at t is equal to 1 second, imagine the object has moved 2 meters. When t is equal to 2 seconds, the object has moved 4 meters away. When this is 3 seconds, the object moved 6 meters. When this is 4 seconds, object moved 8 meters. When this is 5 seconds, object moved 10 meters. Say, I gave you the information of position and time. So how do you mark the points on a graph? So definitely you will take some scale, right? So this is your origin. And let me take time as 1 second, 2 second, 3 second, 4 second and 5 second, that way. And my the position as like 1 meter, 2 meter, or let me take it as 2 meters, 4 meters, right, 6 meters, 8 meters and so on. So how do you mark, right? So you will mark the points. So this is where when time is 1, the position is 2 meters. So here you put a point, and second point is here you will put, like that. Looking at the information, you will get certain dots, right? And what you need to do, all you need to do is you will have to join the dots, isn't it? So when you join the dots, here in this case, you are getting a straight line. And you just check the information. The object is moving equal distances in equal instants of time, right? Say at 1 second it has moved 2 meters, at 2 seconds it has moved 4 meters. It has moved equal distance in equal interval of time. So what is this motion called as? Definitely this is a uniform motion, right? So whenever an object follows uniform motion, and for that object, when you plot xt graph, you will get a straight line. Okay, so this is a very basic point that you need to remember, right? So the straight line, the first point that I'm writing here is, if you get a straight line in xt graph, okay, then it indicates uniform motion. It indicates uniform motion. So this is a very fundamental point one must understand. Okay, fine, very good. So as long as the motion is uniform, you will get a straight line. And what you can come to know through this straight line, one thing I can say is uniform motion in the sense your velocity is constant, right? So when velocity is constant, what about the acceleration? What is acceleration? Change in velocity. When velocity is not changing, acceleration, A is acceleration, A will be 0. Isn't it? Say, this is what the fundamental points that you need to remember if you get a straight line. Acceleration is 0 in this case, velocity is constant. Okay, fine. And another thing is, so imagine I consider any 2 points, right? So this is one point I consider. Okay, so let me call it as x1, corresponding to this point. The distance or the position is x1. Okay, and corresponding to this point, the position is x2, right? And if I draw a line perpendicular to x-axis from this point, and if I draw a line parallel to x-axis from this point, both of them will meet here. Okay, so what is this angle? What is this angle? This angle is nothing but tan theta, right? And what is this tan theta, which is talking about slope, right? So slope of this line. So what do you mean by slope? So imagine, guys, this is your x-axis, right? And the line looks something like this. You see how much extent this line is away from this t-axis. So this is your t-axis, and this is your slope. You see here, slope is nothing but this angle. Okay, so the angle between this line and my t-axis, right? So this angle becomes more and more when this line is away from t-axis, right? So here the angle is very less, but here the angle is more, angle is more, angle is more, right? So as the angle increases, which is that this tan theta angle, as it increases, your slope will increase. Okay, so this is actually, imagine if this has to be on this, and now this line is moving away, right? So more the steepness of a line, more is the slope. This is what we call it as a slope. Okay, so this is what we will call it as slope. So slope is nothing but tan theta, right? Say the more the angle, more will be the slope. Okay, so what I can write, more the angle, more is the slope. Okay, slope is nothing but how steeper is the line. Okay, so how much far the line is going away from t axis. So that is what we mean by slope. And how do you calculate that slope? Say how do you calculating slope is nothing but calculating tan theta, calculating this angle. So how do you calculate tan theta? So we all know tan theta is equal to, it is opposite by adjacent, right? So opposite side is this, adjacent side is this. Opposite by adjacent is what? Tan theta, right? And what is opposite? So what is this distance? What is this distance, right? Say this is x2, this is x2 minus x1. And what is this? What is this? If I, this is the time interval, right? So let me call this as t2 and this as t1. Okay, so let me use the other chalk piece here. This is t2 and this is t1. So t2 minus t1 is time interval, right? So what is this distance? What is this distance? Say just corresponding to this, you have to check, you will get to know, right? So what is x2? 8, right? So x2 minus x1 by t2 minus t1 will give you tan theta. So that is nothing but slope. Tan theta is nothing but slope. I mean, to how much extent this line is away from t axis. Say that's what you are finding out by this angle theta, right? So slope is equal to this much. So x2 is 8 minus x1 is 4 and t2 is how much? 5 minus 3, right? So it is 4 by 2. So that means your slope is equal to 2. And what is this? Actually this is nothing but displacement, right? See, this is x2 minus x1 means what? It is the distance between this point and this point. So this is actually nothing but displacement, right? And this is nothing but time interval, right? So you calculated displacement by time interval, right? So your slope is nothing but displacement by time interval, isn't it? So what is displacement by time interval? It is nothing but average velocity, right? So you calculated average velocity. Your slope value indicates the average velocity value, that is 2 meter per second, right? So what is this 2 meter per second? 2 meter per second is the average velocity. It is the velocity difference between this point and this point. Okay, so that's what we mean by slope. So here the value of slope is nothing but the value of average velocity. Okay, so another important point is value of average velocity sign is this, right? Value of average velocity can be found from slope, okay? So you can find out average velocity like this. So between any 2 points, if you want to find the average velocity, you just draw these lines. Okay, so if I want to find the average velocity between this point and this point, so what you will do? A line from this, and this is the angle you are finding. So how do you find that? Just opposite by adjacent. This difference, okay, in the y axis, and this difference on the t axis, you have to identify, substitute here, calculate and give the average velocity. You have to understand one point here, guys. Average velocity was easily calculated by knowing a graph, right? So when you plot a straight line, it indicates that it is uniform motion, and where the velocity is constant, and if you can find the slope of this line, then that itself is the value of average velocity between any 2 points. Okay, fine. So now we got to know how to find average velocity. Now what about the instantaneous velocity? So let's understand about finding instantaneous velocity. See, first of all, you must know what is the meaning of instantaneous velocity. Instantaneous velocity is nothing but velocity at an instant of time. Velocity at an instant of time. So what do you mean by instant of time? Okay, so just try to analyze how we found average velocity. Say average velocity is the velocity change between the 2 points, right? So it is the velocity between 2 points, but and it is the velocity between the time interval, right? So in 2 seconds of time, what was that speed? That's what we meant by average velocity. But here, exactly at fourth second, I want to know what is its velocity. Then that is called as average velocity. Okay, so exactly at fourth second, what is the speed, what is the velocity, that is called as instantaneous velocity. Okay, say here, if xt graph is a straight line, this is a very important point, guys. If xt graph is straight line, okay, if it is a straight line, instantaneous velocity, okay, so I'll write it as instantaneous velocity as v instant. Instantaneous velocity is equal to average velocity only. So this is really the way you found average velocity. Say for example, I took these 2 points, and this is how I have done, and I found the slope of this line. Slope is nothing but here tan theta. So this difference divided by this difference will give you slope's value. This value. Okay, that means I'm not talking about slope is not a length. Slope is how steeper is the line. See how much this line is how much far from t-axis, right? So that is slope. So that slope you can always find by this difference divided by this difference. Okay, so the way you found average velocity can be applied for finding instantaneous velocity also. So this is one important point that you need to remember. But instead of this, if it is a curve something like this, then average velocity cannot be equal to the instantaneous velocity. Then you have a different method for finding average velocity and different method for finding instantaneous velocity. So now we will discuss when do you get that curve instead of a straight line. When you have a curve, then how to find the slope, that means how to find the average velocity and how to find the instantaneous velocity. That's what we are going to discuss now. Okay, see guys, when you have this information on a board, how do you plot xt graph? You can try plotting xt graph for this information. Say when time, okay, let me just put the axis, and this is a vertical axis. I'll show x, and this is a horizontal axis, and this is t axis, right? Okay, so this is 0. Let me take time as 1, 2, 3, 4, 5, 6, and so on. And this as with a scale, 5 meters, right? And this is 10 meters, and this is 15 meters, and this is 20, this is 25, and so on. Okay, so now if I start plotting, when time is 0, our distance is also 0, right? So when time is 1, then the distance is 3. So here I'll put a point, and then when time is 2, our distance is 9. So here I'm putting a point, right? So when time is 3, the distance is, and for 2 here the point should come, and for 3 where should the point must come? It's 16, right? So 16 is somewhere here, right? So like that, when I go on putting a point, something like this I'll get, right? So if I have to join all these points from origin, how do I join? So this is how I join normally. Is this a straight line? No, right? This is not a straight line, and this is a curve. So, and you see the information, you don't have equal distances in equal time. Time is, yes, it's 1 second gap, but in that 1 second gap, does the distance is same at every interval? No, right? See, equal distances are not covered in equal time. So what kind of motion it is? Definitely it is a non-uniform motion. Okay, so this is non-uniform motion, right? So you get a curve. What is the first point that I would like to write here is curve in xt graph is shown, okay, for non-uniform motion. Okay, non-uniform motion. But okay, so here velocity is not constant, that's it. Velocity is not constant, but acceleration is constant. That you need to remember, guys. So here A is constant actually. You know, it's very nice to say that uniformly accelerated body. This is the xt graph for uniformly accelerated body. Okay, then this is a perfect name. Okay, so here velocity is not constant. Velocity is not constant. So this is a perfect way of telling. Okay, fine. See, whenever you get a curve, velocity is not constant. Whenever you have a straight line, velocity is constant. So this is really very important. So for a straight line, A is 0. But for a curve, A is constant here. Okay, so A is constant here. Is that clear? So this is the difference you must understand. Okay, so we all know xt graph slope. Okay, so this is the graph. This curve itself we will call it as a graph, right? So xt graphs use is to find the velocity, average velocity. So if it was a straight line, it's very easy to find average velocity. But what if it is a curve? How do you find average velocity? Say here, what do we do is, say for example, these are the 2 points, and between these 2 points, I need to find the average velocity. So what I have to draw is, I will draw a line connecting these 2 points. Okay, and this line is what we will call as secant, right? So all these are mathematical terms. Maybe you are aware of all this. So for a curve, when I select 2 points and joining the 2 points, when I draw a straight line like this, and this is called as a secant. Okay, so slope of this secant will give you average velocity. Okay, so what is average velocity here? Slope of secant. Secant is the value of average velocity. So this is really very important. Okay, so slope of secant is average velocity, right? So that's how you will find the average velocity whenever you have a curve. And now how do you find instantaneous velocity, right? Say for example, and say this is the point where I need to find instantaneous, say exactly at a time 3 seconds, I want to know what is the velocity. Then that velocity is what we call it as instantaneous velocity. So for instantaneous velocity, we have to take a tangent. Okay, so just corresponding to this point, draw a tangent. So slope of tangent, right? So slope of tangent will give instantaneous velocity. So this is the difference, guys. Instantaneous velocity. Okay, so this is really very important to understand. So whenever you have a curve in xt graph, average velocity is nothing but slope of secant. How do you draw a secant? Connect the 2 points. Okay, and how do you find the instantaneous velocity? It's nothing but the tangent. Okay, so the tangent at a particular point will give you the value of instantaneous velocity, right? But drawing a tangent at a particular point and all this needs much more information, and it is very quite complicated part. So that's why usually instantaneous velocities we won't find through graphs, right? So it can be found by integral simplification or differential form. Okay, so on using certain mathematical applications like differentiation, we can easily find instantaneous velocity. All that I will tell you in some other video. Okay, like when the concept comes, I'll tell you about instantaneous velocity and instantaneous acceleration. Okay, but I'm just giving an idea. From a graph also you can find the instantaneous velocity. That is, this is how you can find it. Okay, so this is what the information that you must know when you have a curve in xt graph. Okay, fine. So now what I would like to tell you is, in case, okay, so in case if your graph is something like this, xt graph, if you have something like this, what does this mean? This means that velocity is constant, no doubt. Velocity is constant. Why I'm telling as velocity constant? Because straight line you have. Okay, but velocity is decreasing. Velocity is decreasing here. Okay, so here velocity is decreasing, and here the slope is negative, right? So you will have, if I join these 2 points, right? So you will actually have a negative slope, isn't it? So slope is negative. Slope is negative, right? Because the velocity is decreasing, velocity is negative, right? So slope is negative here. Fine. And what about this situation? In case if your xt graph is something like this, right? What does that mean? You see, as the time changes, the position of the object has not changed. Okay, say for example, this is 10, this is 20, this is 30, and this is 40. Right? Say time 1 second, 2 second, 3 second, 4 second. So time is increasing gradually, but the object, you see, it is there in the same position, 40, 40, 40, 40, 40, all through the times. So what does this indicate? If an object is staying at the same position throughout the time, it indicates that object is at rest. Object is at rest. This is very, very important, guys. So whenever you have a line parallel to t-axis, whenever you have a line parallel to t-axis, it indicates that object is at rest. Okay, so whenever you have a graph something like this, it means that velocity is increasing, slope is positive. Okay, so you all know how to calculate a slope, right? So slope is calculated change in the position divided by time interval, right, between the 2 points. So that's how you are finding slope. It's nothing but a tan theta. Okay, and whenever you have a line something like this, it means that velocity is decreasing and you will have a negative slope. And whenever you have a curve, it indicates that velocity is not constant. Okay, it is for uniformly accelerated body. Okay, so here how do you find the average velocity? Velocity, the most important use of xt graph is to find the average velocity. Slope of a line will give you average velocity. If it's a curve, slope of a secant is average velocity. And if you want to find instantaneous velocity, it is a tangent. Slope of a tangent is instantaneous velocity. Okay, but if it is a straight line, the way you found average velocity can be applied for finding instantaneous velocity also. So here average velocity remains equal to instantaneous velocity if you have a straight line. It can be a positive slope or negative slope. Okay, fine. And when you have a line which is parallel to t-axis, it indicates that object is not in a motion, it is completely at rest. Okay, so this is what the summary of xt graph, and this is the use of xt graphs. Now we will see certain questions that can be asked on XT graph, so that you will have an idea how we have to apply this concept and when we have to apply this concept. See the question, guys. They have given a graph. This is a XT graph. See, graph to look at is very much scary, right? But you must know how to read a graph. Okay, so you must understand object from where it is moving to where and how it is moving. Okay, so when you can carefully read the graph, then finding answers for the question is really very easy. So everything is there in reading a graph. Okay, fine. Let's read a graph little later. First, try to understand the question. See the XT graph and calculate average velocity between time -2 to +3. Okay, so time -2 is here and +3 here. So between this time interval, there is a change in position of object, definitely. So average velocity you need to find. And the second question, average velocity between C to G. Okay, so let me mark, this is point A and this is B, position B, and this is position C. Okay, and then this can be position D, this is E, this is F, and this is G. Okay, so you have to find the average velocity between C to G. C is here when the object is here, from here when it has moved to here. So in this gap you have to find the average velocity. And next question, average velocity between -1 to 0, -1 to 0. So in this instance, what is the average velocity? That also you need to find. Okay. And next is instantaneous velocity at 7.5. So here at this point, exactly when the time is at 7.5, where is the point? Yes, here. So here you need to find instantaneous. At this point you need to find instantaneous velocity. And instantaneous velocity at the time 6. That means at this point, even at this point also you have to find instantaneous velocity. Okay. And now I'll help you out in reading a graph. So how do you read this graph? See, actually object has started from here, right? And from here the velocity was increased. Okay. So with almost, it's a light curve, guys. So from the negative velocity, slowly velocity increased and it reached at this point, and later velocity decreased. So with the decreasing velocity it has come to this point. Again velocity is slightly increased. Okay, increased here also, increased, and you see the object from E to F, there is no change in the position. Okay, so if you see point E, it is corresponding to 5 meters. If you see point F, it is corresponding to 5 meters only, right? So this is the area where object has not moved, it has taken a rest. Okay, so here the object is at rest. And now again with constant velocity, with increasing velocity, the object has moved to point G and then velocity decreased. Okay, so maybe the object is moving in the opposite. Velocity decreased means what? The direction has changed. Okay, so let me show the graph here. See, object is here at point A. Okay, and from point A you can see velocity is increased, right? That means the object is moving in a same direction, right? So it has reached point B. From point B velocity is decreased. That means negative velocity. That means it has moved backwards. It means that the object has taken U-turn. Okay, so it reached point C. Again from point C it is moving almost forward. I mean, right? Say automatically from B to C the velocity is negative. From C to D the velocity is positive. Again the direction has changed. That means again you took it took from U-turn. Okay, it took a U-turn, and this is point D. From point D it has moved here. This is E, and here it took a rest. It has not moved for a while, right? So let me take, this has taken a rest. Okay, so this is your F, and again with the positive velocity it is moving, in the sense it's moving forward, and again here the velocity is decreased, it's a negative velocity, right? So that means from G it took a U-turn and it is coming backward. So this is what the motion of an object. So this is how you must able to read a graph. Okay, so this can actually help you out in solving many problems. So important thing is reading a graph here. Okay, fine. So now let us try to answer the questions that they have asked. First one, average velocity between time -2 to time 3. So where is -2? -2 is here, right? So +3 is here. So in this time interval, what is the average velocity? So at -2 object was at this position, and at +3 object is at this position. Okay, so if you join these 2 points, it's a curved graph, right? So you can just put a line here. This is what we call it as secant, right? So this is what we mean by secant. Okay, so now if you draw a line, vertically downwards, and from here horizontal, this is where it meets, and this is the angle you need to find out, tan theta, right? So actually what you are doing, it is I'm just finding out the first question, average velocity at the time -2 to 3. Okay, for this question I'm finding out, and this difference divided by this difference. So what is the difference here? See here it is at, see, this is your initial velocity is 3, right? X1, this is X1, this is X2, right? And here corresponding to this is T1, and corresponding to this, and this is T2, isn't it? So here what is this gap? Actually it is final velocity minus initial velocity, that is 5 minus 3. 5 minus 3 divided by what is this time interval? This time interval, it is 3 minus of -1, right? So what do you get? 2. It is actually -1, guys. Okay, so this is actually -1. Yes, we have done it from -1 only. No, it's actually -1. So 3 plus 1, that is 4, right? So it is 1 2, right? So almost average velocity is around 0.5 meter per second. So this is the answer for first question. Like this, for every information you have to find something like this only, right? So now let's go for the second question. They asked you to find average velocity between the point C to G. Okay, so where is C? C is here. Okay, where is G? G is here, right? So a line from C to G, right? So what is the slope that you get? So G is here, and let me join, say, slope. This is what you have to find. So this difference divided by this difference you have to do. So what is this difference? What is this different? And where is G? It is at 7, right? And where is C? C is at 1. So 7 minus 1, right? So 7 minus 1 divided by time gap is what? C is at 0, G is at 7, right? So here it is 7 minus 0, that is 7, right? So you will get 6 by 7 meter per second is your answer, right? So now coming to the third question, they ask you average velocity between the time -1 to 0. So where is -1? Okay, so here is -1, -1 to 0. Okay, so -1 to 0, -1 is at B, 0 is for the position C. -1 to 0 means you have to find the displacement or average velocity between B and C points. B is here, C is here, right? So this is a straight line only. So this is what the slope, right? So here this difference divided by this difference, this difference, let me call it as x, this difference, let me call it as t. See guys, actually this is the initial position of if you see B and C, object has come from B point to C point, isn't it? So this is the initial position, this is the final position. So what you have to do? You have to do final minus initial. Final position is at 1 in the this y axis, and initial position is at 3 in the y axis. So it is 1 minus 3 you have to do. And what is the time? What is the time? This is the initial time, this is the final time, right? So 0 minus of minus 1. So you will get minus 2 divided by 1, that is minus 2 meter per second. You see your velocity value is negative. What does this negative means? The velocity decreases. You see from B point to C point, object is taking a U-turn. Its direction is changed. So plus to minus. So that is the importance of this sign. Sign will tell you whether it is a positive velocity or negative velocity. So it's a negative velocity, right? Negative velocity means actually the object has taken a U-turn here. Okay, fine. So next question guys, find the instantaneous velocity at a time 7.5. So instantaneous velocity at time 7.5, right? So where is 7.5? Yes, 7.5 is here. So at this point you want to find the velocity. I told you whenever you have a straight line in xt graph, instantaneous velocity can be calculated as average velocity. So here if I asked you to calculate average velocity, how do you calculate? It is the velocity between this and this point. So this is how you will make, right? So this difference divided by this difference divided by this difference, right? So this is what the angle you are trying to find out. So what is this difference? So where is our C? C is at 2, okay, G is at 7. This is the initial position, this is the final position, right? So final minus initial. So 2 minus 7 divided by what is the time gap? Time gap, you see this is T1, this is T2. T2 is at 8 seconds, T1 is at 7 seconds. So 8 minus 7, it will be 1. So it is minus 5 by 1, right? So this one is our minus 5 by 1 meter per second, that is minus 5 meter per second. So here also you see the velocity is negative, that means the object is changing its direction. Okay, so velocity is actually decreasing. I mean, it's not actually decreasing. Okay, so here the direction is changed. That is what the meaning. Okay, so this is the initial velocity, this is the final velocity, right? So initial, final position, velocity is something like this. So it is negative value, right? So now what is the last question? Instantaneous velocity at a time 6. Instantaneous velocity at a time 6. That means at this point you have to find instantaneous velocity, and this is also a straight line here. So just a slope of this line, if you can find, that will be your answer. So find the slope of this line guys, that means this difference here, check it out, divided by this difference. Okay, so find out and let me know the answer in a comment box. Post the answer in comment box. So that's all about the different models of questions that can be asked on XT graph. Okay, so this is how you must know how to read the graph, and you must know how to calculate the slopes when it is asked in between different points and between different times. Okay, so okay guys, video has become too much lengthy. I just wanted to cover VT graphs also here, but since it has become too much lengthy, I'm keeping this VT graphs for next video, and do watch my next video for VT graphs. Really, VT graphs has lots of information to know about, and we can calculate many things from VT graph. and not only that, how to convert xt graph into vt graph and vt graph into xt graph. That is also a very very important concept, and we will look at some questions based on that concept also. So do watch my next video also, that is the continuation of this video actually. Okay, so do practice. The more the questions you practice, more perfect you will become actually. So first thing is you must able to read the graph very nicely. Okay, and then you must understand where is the velocity going to be a positive and where it is going to be a negative. See, velocity positive means object is moving in a positive direction. Velocity negative means automatically when a velocity becomes negative, it means that the object is going in the opposite direction. You see here the velocity positive, automatically here the velocity has become negative. That means here the direction of object only has changed. Okay, so that is all about xt graphs, and see you in my next video. Do watch that. That's really going to be a very very interesting video. Okay, and share the videos with your friends also, and do subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you so much.